Good morning, everybody. Our next lab is about distillation trainer. We have a binary distillation trainer over here. Your lab number 4 is about identifying the distillation system and its components. You know that any distillation system consists of different components. Basically, they contain a vertical shell where the separation of liquids are carried out, and then there will be an overhead condenser. Here we have an overhead condenser over there. Over there is an overhead condenser, and then there is a reboiler to provide necessary vaporization for the distillation process. Then there will be a reflex drum, or here the reflex drum is over here. Anyway, I'm going to come back to this later on and show you the components separately. I just wanted to give you an overall idea about the distillation system, where the main components are the shell or the column itself, and then there is a condenser, and there is a reboiler, and also there is a reflex drum. Okay. In this distillation trainer, you know that in the class we have seen that the distillation systems are used to separate the components of mixtures. The mixture can be a binary mixture or it can be a multi-component mixture. Binary mixture means it contains only two components. Here the trainer is a binary distillation trainer. See, binary distillation means it separates components of two components of a two-component mixture. Here the mixture that is being used is a mixture of methanol and water. See, here we have a feed tank over here, which stores the feed mixture. Here, as you know, the mixture used is methanol water mixture, and we are using a 50% solution over here. See, in this one, as you know, the separation is based on the difference in boiling point. The driving force of distillation is the difference in boiling point. Here one component is a low volatile component and the other one is a more volatile component. Or the one is lighter component and the other one is heavier component. Here we have two components in the mixture. One is methanol and the other one is water. Methanol, it has got a boiling point of around 66 degrees centigrade, whereas water has got a boiling point of around 100 degrees centigrade. That means the methanol component is the lighter one and water component is the heavier one. See, here we will be the feed is over here, which is a 50% solution. Our aim is to separate pure methanol from top and water from down. Here the feed, which is normally a 50% mixture, is admitted to the middle of the column. Here the middle of the column is over here. See, here totally the distillation tower consists of 9 trays. The trays, I have told you in the class that the column internals can differ from either it can be a tray tower or it can be a packed tower. Here we have a tray tower, and in tray towers columns, basically there can be 3 types. One is bubble cap tray, the other one is sieve tray, another one is valve tray, which shortly I will be showing you all these type of trays. Here we have a bubble cap column. Come over here and see inside from go up top. Go top over here. So you can see the bubble cap over there, and the purpose of the bubble cap is to provide sufficient vapor liquid contact. See, whenever the feed is introduced over here in the middle tray, whenever the feed is introduced over to the middle tray, this region is known as flash zone, where the separation of vapor and liquid will be happening, because there will be definitely there will be a pressure difference over here. We are maintaining a pressure difference over here, and whenever it enters into a region of lower pressure, it flashes and vapor will be going up, and the liquid portion will be going down the column. The vapor which is going up will mainly consist of methanol, and the liquid that is coming down will be water. However, the one which is going up, it may contain some heavier components, and the liquid that is coming down will contain lighter components as well. Our aim is to make sure that the top vapor is consisting of almost pure methanol vapor as possible, and whenever the liquid comes to the bottom, it should be containing water as possible, heavier component as possible. That's why the section below the feed tray is known as stripping section, where the lighter component will be stripped out. Or if at all there are some methanol coming out along with the water down to down the column, then the lighter component, which is methanol, will be stripped out in this section. That's why it's named stripping section. And whereas the portion above the feed tray is known as rectifying station, where the concentration of the lighter component will become more and more. And finally, the pure methanol vapor, maybe it will be 95%, 96%, whatever may be, that will be taken out from the top, and it will be led to the condenser. You can see a condenser over there. Condenser is essentially a heat exchanger. Here we have got a plate and film heat exchanger over there, which condenses the vapor that is coming out from the top of the tray, from the top tray. And the vapor from the top of the tray, the product will be leaving in the vapor phase, and then it will be passing to the condenser, where it will be converted to, or it will be changed to liquid. From there, the condenser, the condensate, or the overhead product will be going to the reflex drum. The condensate will be going to the reflex drum, or a reflex accumulator, where it will be collected. And from this accumulator, a portion will be returned to the column as reflex, and the other portion will be taken as top product. The top product, overhead product, will be collected in the column over here in B404. See, this is the one. Here, the top product will be collected, and this one is the reflex accumulator. As I said before, a portion will be returned back to the column, and another portion will be taken as top product. What happens to the bottom product? Bottom product, you see, still if it may contain some lighter portion that will be heated in using a reboiler. Sorry. Here the reboiler is an electric type reboiler, and here the bottoms will be heated again, and the boilers will be reintroduced to the bottom tray. This is about the overall picture about the binary distillation trainer. And it has got, you see, we have got sample points for all the trays. You see, it has got 9 trays, and from each tray we have a sample point. We can collect the samples from this one here, and then see the composition. You see, as you go up the tray, the concentration of methanol, or the composition of methanol, will be going higher and higher. You will be getting lighter component concentration more and more. See, we will be able to determine the composition in each tray. For example, when it comes to tray 1, it will be mostly consisting of water. Water will be predominant over here, and whereas it comes to tray 9, it will be methanol that will be more in concentration. Based on the efficiency of the separation, we will get the purer component from the top. In the lab, what you are supposed to do is I have given you the description about the distillation trainer. You need to go through the distillation trainer and understand the main components of this trainer, and then you may need to answer some questions that are given at the end. See, it basically consists of some questions regarding the basic distillation trainer, about this trainer, and also it is asking you some information about the components of the boiler feed mixture, distillation feed mixture. And you may have to find out the actual boiling points by referring to the safety data sheets, or from the internet you will be able to find out the physical properties of the components. I think by going through this explanation, you will be able to answer the questions that are provided in the lab. Thank you. Yes, I was talking about the column internals. See, here we have got a demonstration unit with a demonstration unit for a distillation column with different internals. You can see the bubble cap, caps over here. Then you can see the valve tray over here. You can see the sieve tray also over here. 3 types of trays are given over here, and the top portion consists of packings. See, here we have a structured packing, and here there is this packing is known as Rashik rigs. The purpose of the packing is to give better vapor liquid contact. Right? The vapors will be rising up the column and liquid will be going down the column. The purpose of the tray is also the same thing. In some columns, we will be having only bubble caps, or some columns will be having valve trays, some columns will be sieve trays. And some columns we may find combination of tray and packing as well. But most of the columns, either packing columns or tray columns. Having said that, some columns have a combination of, internals. Here also, you can see that normally in the top of the column there is a distributor. This is known as liquid distributor, where the feed will be distributed uniformly across the packing. In order to make sure that the liquid is being distributed, uniformly, there is a liquid distributor over here. This is just only for the demonstration purpose. We will try to show you the action, but it's not the real replica of the distillation column, just for the demonstration purpose only. Getting distributed over here. This is like a reflex over here. It's not like in the actual column. Normally, it's admitted to the middle of the column. Here, the liquid is being distributed over here. For example, the reflex, which is a part of the overhead condensed product, is being distributed over the column. Just for demonstration purpose, we are admitting air from down and water is coming from the top. And this trays or packing, it provides sufficient area of contact for vapor and liquid, thereby providing heat transfer. See here, in this one, you can see that the one which is being responsible for holding the liquid over here is known as weir. This is a weir, whereas this one, which permits the flow of liquid from the first one tray to the next tray, is known as downcomer. This is the downcomer and this is the weir. See, this weir helps for the liquid holdup. See the based on the air flow rate the liquid, the valve tray, you can see that it tries to lift up from there so that it will allow vapor to bubble through the liquid which is being held over the tray. See, this is a seal tray. Through this seals, the vapors are coming up, whereas the liquid will be going down through the downcomer. And this seals allows sufficient vapor liquid contact.